Okay, good afternoon, everyone. We will start with our next session. For the next, uh, we have with us Professor Vaishali Rajurkar, ma'am, which is work. She is working as a assistant professor in civil engineering department at Sri Ramdeva College of Engineering and Management, Nagpur. She has completed B in civil engineering in 1997 from Pusat Amravati University. She has completed M.Tech in Geotechnical Engineering in 2006 from Ramdeva College of Engineering and Management, Nagpur. She has submitted her PhD in 2022 from RCERT Chandrapur in the field of geotechnical engineering. Professor Vaishali Rajurkar has 20 plus years of work experience in the field of teaching to undergraduate and postgraduate courses. She has supervised more than 50 M.Tech theses and 20 BE projects. She is also a member of Indian Geotechnical Society, India. Professor Vaishali Rajurkar has about 23 papers in her credit that includes publication in journals and conferences of national and international level. She has 8 copyright in her credits and got 2 silver medal in NPTEL courses. She has delivered expert lecture in various STTP and regional training center of PWD and irrigation in the area of geotechnical engineering. She has actively participated in the lecture series of Foundation Engineering under AICTE Prerna scheme. She is actively involved in consultancy work of geotechnical engineering carried out by the Department of Maharashtra State Police Housing Corporation. Now I request Vaishali ma'am to start with the session without delaying it.
Sharing you my knowledge regarding the importance of geotechnical engineering and infrastructure development. Basically, what is the importance of geotechnical engineering and where it will be required? Basically, geotechnical engineering is a very, very important branch in the infrastructure development because we all know that whatever structure we have designed, the structure is in a very good condition. The or whatever structural designer is very good, whatever good material we have used, and if the soil conditions are not in good condition, then the structure will not in a stable condition. So before starting the session, I just wanted to share some of the case studies that you all knows about it. Just what is the importance of, just to know the importance of geotechnical exploration, I just wanted to share some of the case studies with you. So why the soil investigation is important? In the first one, I will just wanted to share some of the knowledge regarding the Leaning Tower of Pisa. As we all knows, it comes under the seven wonders. Basically, it was constructed in the city Pisa in Italy. which was started in 11th 17th century, and which was taken around 200 years for its completion, because at that time there was no invention of the concrete, and therefore all the constructions are made with the stone itself. And again, the load bearing structure is having a very thick wall. Therefore the construction, during the construction, as the structure, before starting the structure, some of the soil is getting excavated and found to be good. Therefore the construction was started. But due to the self-weight of the building, in the at the second story itself the leaning was started, and you know all the example of that. And due to this leaning, because that time that much important technique was not developed for the exploration, and therefore whatever technique was that time, after the at the base of that technique the construction was started, and it was taken around 20 years for its completion. Due to the leaning was started at that time. So the basic aim or basic reason is the differential settlement. As if the whole structure is getting settled in one issue, but the settlement as occurs due to the some part of the pizza was some part of the tower was settled than the another, and therefore it was more dangerous. So
काय झालं का?
हम्म, ठीक आहे. का आता हे आता पीपीटी नाही दिसत आहे यार, काय करणार बकवास. हॅलो.
Hello. Yes, ma'am. Now your PPT is visible, ma'am.
ते ते तर काल लावलं तुम्ही. वीडियो शेयर होता क्या देखती हूँ. नहीं हो रहा है सर, जाने दीजिए. ये वीडियो नहीं हो रहा है, इसको लिंक मांग रहा है ये. डाउनलोडेड वीडियो ही हो रहा है शो. ठीक है ना, जाने दो. अभी स्टार्ट कर लेते हैं, ऑलरेडी बहुत लेट. हाँ ठीक है, स्टार्ट कर लो. Good afternoon, everyone. So today we will be discuss about the importance of geotechnical exploration in infrastructure development. So all we knows that in the developing countries like India, infrastructure industry is growing in a very fast rate. But the importance of geotechnical exploration is equally important for the construction and for the infrastructure development. As we know, the constructions are made in a very proper manner. The structural design is made good, and the material used for the construction is very good. But if the structure, the soil which is supported structure is not in good condition, then naturally there is a failure of the structure. So all we know some of the example of the geotechnical exploration where the proper investigation and the proper construction care was not taken. There was a disaster taken place. So we will just, before going for the exploration program, we will discuss some of the case studies related to the geotechnical exploration. So this is the example that we all know. This is the Leaning Tower of Pisa. It was constructed in the 1170, and which was started leaning at after the construction of the second floor itself. It was at that time there was no invention of the concrete, therefore all the constructions are made with the stone. Secondly, the constructions are the load bearing structure, therefore the width of the foundation as well as the width of the wall is very high, and it was constructed with the stone. The initial weight or the dead weight of the structure was very high. Here the proper investigation was not taken because at that time, though there was no such invention techniques was available, the soil is explored up to a certain depth and found in good condition, and the construction was started. But due to the self-weight of the structure, the leaning was started at the time of story itself, during the construction of second story itself. And the main cause of the settlement was settlement. Many times a complete settlement is quite preferable instead of a differential settlement. So here, some of the basic reasons behind this: the material used for the construction was mainly a stone. The tower was started to lean during construction because of foundation was built on soft marine clay, which is a compressible in nature and hence the difficult to support the dead weight. 30-meter marine clay was available 10-meter below the surface of the tower, where it was taken around 200 years for its completion. Again, for the rectification also, the tower was uh, closed for 10 years around for the rectification measures. Now, the third example is the recent example, that is the we all know China is a developing country where the all proper care during or before the construction was taken care. Here we can just discuss one of the building which was constructed in Shanghai, China, and the construction was constructed at the River side. The building was slender in structure, having cross-sectional area is less as compared to height, and it was taken or collapsed in the month of June 2009. One of the another very important thing that you have to keep in mind, that is the water. Water is a enemy of geotechnical engineer or enemy of soil. When there is entry of the moisture, the strength of the soil is reduces to 50%. Therefore, most of the failures was taken place during the monsoon only. So here the failure was taken place in the month of June, and it was due to the human error. Here you can see this is the actual construction which are made over the bank of the river. This is the reservoir, and here the constructions are made. You can see these are the four towers which are constructed side by side, and the slender structures are there. Even the constructions are made in 2009. The proper investigation was carried out as per the geotechnical exploration was carried out. The design is made according to the soil available, and as per that, the pile foundations are designed. Here, as per the all cases, piles are inserted up to a proper depth, but it was actually loaded pile, and here the load is lateral. You can see this is the schematical diagram of a construction. This is the construction where, as per the soil condition, pile foundations, particularly actually loaded piles, are designed. Then, in the month of June, there was a construction of garage, which is underground garage, and the height the garage is 4.5 meter from the ground level. The excavation is made at the left hand side of the tower, but here the human error was taken place. The soil which is excavated from this part is dumped behind the tower, and there was a continuous rain. Here the soil is in a very loosest condition. All the excavated soil is dumped behind the construction, and there was a continuous rain. Due to the continuous rain, the soil is getting completely submerged, and same time the soil is getting submerged completely, which exert the load over the wall, and the load coming over here is a lateral load. Second, on the left hand side, due to the continuous rain, there was a scoring of the soil surface. This is the exposed soil part, and there is a continuous scoring of the soil is taken place, due to which this part of the pile is exposed, whereas the another part is completely loaded, and the load which is expected to be a lateral load. While while the piles are designed only for the axial loading condition, and here the load came from the lateral side, where the piles are not designed to take a lateral load, and there was a complete cutting of the pile was taken place, and which results in a collapse of a building. So this is the human error, we can say, where during the construction it was okay, but while constructing the garage, the proper care of the dump was not taken place, and another want the water. So here you can see the brief history. Excavation was made for the underground garage up to a depth of 4.6 meter from the ground level, where the excavated material, that is soil, was being dumped up on the north side to a height of 10 meters. Due to a continuous rain, the dump soil is loosely spaced and becomes saturated completely. The building experienced uneven lateral pressure from north due to a saturated soil mass, where the it was greater than the pile capacity, and therefore the complete collapse of the building was taking place. This is the third example, that is the Uttarakhand disaster. We all knows that the Uttarakhand disaster, which was taken place in the month of June 2013. What was the major causes? You can just see the picture where all the constructions are made over the sloping ground, and the constructions are in a proper intact stage. But these constructions are failed, or the structures are failed due to the unsupported soil mass. Here you can see the soil mass itself slide down. Due to that, the complete structure is sliding down before or without any damage to the structure. So all these constructions are made over the sloping ground, and the proper care is not taken during the construction. Therefore, such disaster was taken place. What was the major reason behind it? There is a complete landslide and a cloud burst. The main reason, that is cloud burst and landslide. Constructions are made over the sloping ground, which is an unsupported soil mass. Previously, I told you that the unsupported soil mass are very dangerous, where the constructions are made over the sloping ground. We have to take a proper care for the construction because it is an unsupported soil mass. Then the structure are in intact stage, whereas the failure of the structure is due to the sliding of the structure, that is landslide. Disaster cannot be stopped, but the intensity of disaster can minimize if the proper care is taken during the construction. Then the another example is this is the another example, which is from the village Marin, which is near Pune, and it is completely swiped away in July 2014. So here you can see the construction of this village is made over the base of the hill. Here you can see this is the complete hill, and the village is situated below at the toe of the toe of the hill. Here, the complete village is swiped away during the month of July. Again, due to a heavy rain. What is the reason? In the month of July, there was a complete, around 3 to 4 days, there was a complete rain, due to which the landslide occurred in the village Marine in district Pune. The landslide, which hit early in the morning, was caused by a burst of heavy rainfall, had been overrun with mud, and more than 200 people have been buried in the landslide. What are the major causes? That is negligence of geological fact and lack of soil investigation before any development process. Negligence of geotechnical fact means all the constructions are made over the sloping ground, where the proper care was not taken during the construction, and the another cause is deforestation, where the without any knowing any geological features, the expansion of the village was taken place. Then this is the next example of British era bridge washed away near Ratnagiri on 2nd August 2016. Here, this is also very well known to you. That is again in the month of, or it is in during the monsoon, August 2016. There was a continuous rain, and you can see this bridge was tested for NDT just 3 4 month prior to this accident. So you can see there was a complete rain, and around 72 hours there is a continuous rain. Due to that, the soil is getting completely submerged, and there is a continuous wave pressure because the water is completely, the river is completely swelled. So the colonial era bridge on Mumbai Goa highway caved due to the heavy rain. Structural audit was carried out around 3 to 4 months before the disaster. Failure was taken place due to the heavy rain of around 72 hours, which lashed the area, which caused swelling of the river and high wave pressure. Upward pressure due to submergence of river bed and complete collapse of the bridge due to the above reason. Then this is the another recent example which was taken place in, again it is in the month of June 2020. So this is the three-storied building which was constructed along the canal side. You can just see the, this is the canal where the construction is made along the or over the bank of the canal. Even though the permission was not granted for such construction, still the construction is made over the ground, and during the construction itself there is a complete collapse of the building is taken place. So here you can see a three-story building suddenly collapsed into a canal in West Bengal, India in June 2020. The incident was happened by a heavy rainfall the day before. The building was under construction. A house was built very close to the canal, a fact that violated the state's building regulation. The failure was associated due to the excavation work conducted in the nearby canal, and here, due to the exploration, building foundation was exposed prior to the failure and shows cracks in the foundation. So these type of building, you can see there was a complete collapse, and again this is the construction which is made over the unsupported soil mass, means over the sloping ground. Here you can see the proper foundation. If the proper foundation is designed, in that case this collapse can be avoided. Then this is the another example. This is the live example in 2021. Landslide swept away the multi-storied building in Shimla in September 2013. Here there is a video link, but at this stage I cannot share that video. So here you can see this is the complete collapse of the building. Again, it is again over the sloping ground. Construction is made over the sloping ground by which it is being collapsed. So the incident was occurred on September 30, 2021 in Shimla, India. The eight-story building was situated on a slope where the landslide struck reportedly after heavy rainfall. The landslide mass before it topped and was subsequently reduced the rubble, and the foundation of buildings upward have suffered score, and many be a prone of such failure. This is the very common scenario that we can see in the hilly areas there due to the continuous rainfall and the sliding of the soil mass. Now, from all the reasons, you must have an idea what how the exploration program is important for the successful completion of the building. So, just will now focus on the importance of geotechnical exploration and what are its different techniques. So here why we are carried out the geotechnical exploration and what is meant by exploration. Exploration means the complete knowing the fact of the that soil, where the soil is in a compressible nature, where the groundwater table is live, which type of soil is there, at which depth the hard rock is available, is there any compressible layer exists. So all these fact we have to know before prior construction. So in that case we are going for the geotechnical exploration program. From the exploration program, what kind of information we will get? Here, to select the type and depth of foundation means where the soil is in a proper condition. Soil is in a escape. It is in a. It's able to resist the load which is coming over it. That all things we have to check prior. After exploring the soil, after exploration the strata, we will know which type of soils are available, what is its bearing capacity, is the soil is able to sustain the load which is coming over it. So all these things, or all that fact, we can identify after the exploration program. So first, to select the type and depth of the foundation for given structure, to determine the bearing capacity of soil, to estimate the probable and maximum differential settlement, to establish the groundwater level and determine the properties of soil, to predict the lateral earth pressure against a retaining wall, to select suitable construction technique, to solve the potential foundation problems, to ascertain the suitability of soil as a construction material, to investigate the safety of existing structure and suggest a remedial measures. So these are some of the important things that we will get through the exploration program. Now, there are different phases of exploration program, and as per the soil conditions available, as per the construction of various structures and the site available, we have to decide whether we have to go for the reconnaissance survey, whether we have to go for the primary exploration, or whether we have to go for the detail exploration. Now, again, in all the types of exploration, here also there are three phases of exploration. One is site reconnaissance, then second is primary exploration, and third is the detail exploration. So a complete site investigation wall consists of site reconnaissance. If suppose the constructions are like a massive structure such as dams, bridges, flyovers, then the multi-storied constructions, so these type of constructions are there, and we are having the change to site, we are having the option to change the site, we will first go for the reconnaissance phase. So, what is meant by actually site reconnaissance? Actual site inspection, collecting the general information and already existing data, such as study of geological formation, seismic maps, contour maps, etc. Then study the site history in previously used quarry, agricultural land, industrial unit, etc. To judge the general suitability, decide exploration techniques, and here, if the constructions are like dams, bridges, these constructions are made over the ground where the soil is in an ideal condition. If the soil is in not ideal condition, we can change the site, or we can locate the another site also. So if such options are having to change the site, then only we will go for the site reconnaissance and we will carry out a geophysical method. Once the geophysical method carry out and it shows that the good quality of soil condition is available over the proposed site, or the hard rock is available at a certain depth, then only we will go for the preliminary exploration program once the site is decided to go. If in the first site reconnaissance itself we will find that the soil is not suitable for the intended purpose, then we will never go for the primary exploration and we'll directly go to the or change the another site. So once we will get the from the geophysical method, we will identify the soil is in a good condition, we can go for the construction. In that case only we will carry out the preliminary exploration program. In this exploration, we will get the approximate picture of subsurface condition, which is relatively low cost. The information obtained should be sufficient for design and execution of the minor and routine engineering works. So here, when this preliminary exploration program can be carried out, where the construction of a small residential building, or it may be a light structure, it may be a road construction, where we don't have an option to change the site. If the plot is situated, if suppose I want to construct a multi-storied building in some crowded or in a commercial areas, in that case, even though the soil condition is not good, still we cannot change the site. So in that case, we will never go for the reconnaissance phase. We'll directly go to the preliminary exploration. We will carry out the sampling method, that is penetration test, or it may be a standard penetration, static cone penetration, and dynamic cone penetration test. These all are comes under the category of the sampling method. So in the preliminary exploration program for the constructions like residential building, roads, and light structure, we will go for the sampling method, that is the penetration test. And sometime instead of this method, we will go for the exploratory drilling and sampling, where we will carry out the trial pits and trial boreholes to know the exact soil condition of the soil. After getting the preliminary idea of the strata available, then we will go for the detail exploration. In the detail exploration, we actually carry out the detail exploration program, just carry out a different number of boreholes, taking out the soil sample from different borehole at different data, and then we will just send it into the laboratory for further investigation. So here, detail investigation, that is for the multi-story construction, dams, bridges, flyover, we are carrying out the bearing capacity test. These are the in situ test, where plate load test, pressure meter test, vane shear test, and the investigation by the trial pits or trial boreholes. Just to obtain the trial boreholes and trial pits, we will take a undisturbed sampling, that is UDS, from different locations and send it into the laboratory. Once the soil is properly evaluated through a laboratory methods, the detailed reports and boring log data is prepared. Now we will discuss the reconnaissance phase in detail. That is, first we will discuss the geophysical method. What is the utility of geophysical method? In the geophysical method, we will get an approximate idea of a strata available within a short period. But again, this is a approximate method. We cannot 100% rely on the method. We will just take some idea to how, when whether we go for this site or not. So here, these methods are very quick and fast method. We can evaluate the whole soil strata within a 1 day itself. But whatever data obtained is not a completely reliable one. Whatever data obtained is a it is a approximate one. So here, this can be used to determine the depth of bedrock at a site, or dams, earthfill, bridges, or harbors. In studying the potential landslide zone, and to determine or locate the extent of construction material. And the last one is locate the groundwater table. So the first method in this category is refraction method. That is the seismic refraction method. So here in the seismic refraction method, suppose it is assumed that the soil is a layered deposit and having softer layer is at the top, and when we are going deeper and deeper, the soil is become denser and the strong. In that case only the method is suitable. When the soil is in a soft condition, then there is a somewhat stronger soil than the first one, and third layer is again the strongest in all the two layers. Means here, this type of profile is available only that case the it gives better result, or it gives a reliable result. In this case, the shock waves are created with the help of a small explosive, or just by a impact of hammer. With this explosive, the vibrations are created, and that vibrations are entered into the soil zone. Then these shock waves have different velocity in different wave. Suppose this is the loosest layer, then v1 is the velocity of the first layer, which is having a lower velocity. Then the soil is become stronger as compared to this one. Then v2 is the velocity of the shock waves which is traveling through the second layer, which is value, numerical value is greater than the first layer. And third layer is suppose the bedrock, where the velocity of shock waves is highest out of these two and travel through this layer. So in this case, with the help of a shock waves or shock explosive, the waves are created which are traveling from the different layer with a different velocity, and there are geophones attached over the ground floor, uh, gr- um, over the ground level, which records the time of arrival of each wave. So just from the data obtained, the graph is plotted, and the basic principle is that the method is based on the principle that the elastic shock waves have different velocities in different material. At the interface of two different material, the waves get partly reflected and partly refracted. Seismic method of subsurface exploration generally utilized the refracted waves. The assumptions that previously we have discussed, that the equation of the refraction survey are derived based on the assumption that the subsurface strata are such that the velocity of shock waves increases as the depth increases, or it is assumed that v3 is greater than v2, v2 is greater than v1. So here you can see the 3D view of this. Here we have created a explosive, or with the some another method we will create a shock waves. That shock waves are entered into the first layer, second layer, third layer, fourth layer, and fifth layer. But here the data or the strata should be such that the softer layer is at the top, whereas the denser layer is at the bottom. Only in such cases it gives a better result. If the harder layer is at the top and softer layer is at the bottom, in that case it will not gives you the reliable result. Once you get that strata of the shock arrival, the time of arrival of each wave, we will plot the graph between the distance from the source on the x-axis and y-axis shows the travel time of each of the wave. And here the graph is plotted between these two, where there is a change in the slope. This change in the slope shows the change in the velocity, means the change in the strata. Here, maximum steeper. Here you can see the slope is more. It indicates that the velocity is less. Means the velocity is the reciprocal of slope of each segment. Slope is greater, velocity is lesser. If velocity is less, the soil is become a softer one. Here you can see the slope is very not steep, it is a flat slope. Flat slope means the velocity is more, because velocity is the reciprocal of the slope, and when the velocity is more, it shows the soil is in a good condition as compared to the this soil. By this way we can just have an idea about the velocity of this layer, and from the velocity, that velocity we can correlate with the standard chart to get the which type of velocity we are using for the particular layer. Velocity, we can correlate this velocity with the standard to get the idea about the soil state. Then the limitation. Whatever principles or whatever assumption we have made, the assumption is not true. In that case, that is the limitation of the method. The method cannot be used in hard layer with greater seismic velocity overlies a softer layer with smaller seismic velocity. The method cannot be used for the area covered by concrete, asphalt pavement, or any other artificial hard crust having high seismic velocity. If the area contains same consideration, ground features such as buried conduits, irregularly dipping strata, irregular water table, in that case, the method is not suitable, and it may require a very sophisticated and costly equipments, and whatever data obtained, that has to be interpreted with the expert only, otherwise as per the person the data may vary. Then the second method in this category is electrical resistivity method. The method can be suited only for the strata having different electrical resistivity. This is the another geophysical method of subsoil exploration, and that is electrical resistivity. Mainly, this electrical resistivity method is used for knowing the to know the groundwater table, because the resistivity is greatly affected by the entry of the moisture. If the density if the resistivity of some of the material is suppose 500, when the water is enters, it suddenly drop down to the 200, and that 500 to 200 drop shows there is a entry of the moisture in the particular layer, and here the rock and dry soil is having greater resistivity as compared to the saturated clay. This is the electrical resistivity method, where the four electrodes are used. These four electrodes are in the form of metal spikes. It is inserted into the soil, where the current is supplied from the outer one and the potential drop is measured over the inner one. So this is the electrical resistivity method. And here the basic assumption is that whatever is the distance between the electrode, that much data we can evaluate it below the ground. Suppose here we can see 2 meter is the distance between the geophone, then 2 meter below the ground level, it will evaluate the soil. And mostly the method is useful for establishing the boundaries of groundwater table. Here you can see this is the actual picture. Now this is the part of the uh, reconnaissance phase. Now we'll come to the preliminary exploration. So as we have already discussed, preliminary exploration is mostly used for the construction which where we don't have option to change the site, such as construction of multi-storied constructions, construction of towers in a crowded area, highways or flyovers, like these structures where we cannot go for the reconnaissance phase. Means we know that we cannot change the site even though the soil condition is not ideal. In that case, we'll directly go for the preliminary exploration program, and the sampling methods are used. And most commonly used sampling method is a standard penetration test, which is commonly known as SPT. Basically, the test has been suitable for cohesionless soil, but nowadays the test has been used for the cohesive soils only. For sandy soil, from the test data, we will get the relative density and angle of shearing resistance. And for cohesive soil, it shows you the unconfined compressive strength. Then, in the will directly, that is the entirely a different topic. Standard penetration test is the entirely a different one. So we will just come to the detail exploration part. Detail exploration part, in this, the exploratory method means the open excavation, pits or trenches. And if the condition, or if the exploration has to be carried out up to a small depth, it may be up to 3 meter or 4 meter or 5 meter, then only we will go for the open excavation. If the depth of exploration or depth of excavation is increases, in that case we will just go for the boring, because it is expensive one. Secondly, it is also a very risky and not economical also. So here we'll first see the pits and trenches. Pits and trenches are excavated at the site to inspect the strata. Shallow pits up to a depth of 3 meter can be made without providing any lateral support. For depth greater than 6 meter, boreholes are more economical than open pits. Here, the method is not economical when the depth of exploration is more, and but at the same time, here in the pit you can see the whole structure of the soil, whether what are the different conditions of the soil, what are the different layers, what are its exact thickness, how the soil strata is changed, where the groundwater table is exactly located. Means from the open excavation you will get a whole picture, whereas from the all previous method we cannot get the whole profile of a soil structure. Means this method is more accurate as compared to the all. Here you can see these are the open pits. In open pits, here you can see the different soil condition, what is exact thickness of it, and how whether the soil is collapsible or not. And here you can see this is the structure: L1, L2, L3, L4, L5. Means this is layer 1, layer 2, layer 3, layer 4, layer 5, layer 6. Here the proper description or the detailed description of the different layer is given. So layer 1, sandy soil, color, what is its color, then what is its finding, and chronology. As per this exploration, we will get an exact idea about the strata. This is the difference between the pit and the borehole. You can see this is the borehole, which is having a very small dimensions as compared to the pit. Here you cannot identify the proper soil condition. Only some strata, only this much strata you can get it through a muck, which is we have obtained after boring. But here you can see all the things are in a proper manner. Here this is the trench. Now what is the difference between the trench and pit? This is pit. In pit, we can get a dimensions L by B. Here and D, L, D and B, all the three dimensions are known to us. Where in the trenches, the length is very high as compared to its width. Width is small, depth is okay, whatever it may be depth, but the length is very high. It permits visual inspection of subsurface condition in natural state. Maximum depth is limited to 18 to 20 feet. Means we can go up to 6 meter only with support, and without support we can go up to a depth of 3 meter. But when the depth of exploration is increases, in that case we have to provide a immediate support, so that the caving should not be taken place, because it will be again dangerous and risky also for the peoples those who are working into the pit. Then the another example is drift and shaft. Now what is exactly drift and shaft? Drifts and shaft, These are the vertical and horizontal tunnels which are made into the hillside to determine the nature and structure of the geological formation. It is useful for establishing the minimum limits of excavation, limit to reach the sound rock, and for locating faults and shear zone. Shafts are the larger size vertical holes made into the geological formation. It may be a rectangular or circular in section. These are used to reach a particular strata up to a depth of 4 meter and more. As earlier we have discussed, the methods open excavation is suggested for 3 meters without support and 6 meter with support. But here this drift and shaft are the holes which are made up to a larger depth, having cross sectional area more, and these are made for a particular purpose only, such as for the tunneling structure, for the underground structure, where we have to check a actual condition, actual geological formation, where there is a some sound rock is there, or there are faults or shear zones like this. Here you can see this is the larger size hole. Here it is a rectangular in section. Here you can see this is in a square in section. This is the horizontal hole which is made into the hilly area just for the construction of tunnel or underground structure. This is a vertical hole having dimensions are larger and depth is very large. Second one is, this is drift horizontal hole, this is shaft vertical hole. Then when the depth of exploration increases, suppose the depth of exploration is more than 10 meter, more than 4 meter, 5 meter, 6 meter, and many time we have to explore the soil condition up to a 20 to 25-meter depth also. In that case we will never go for the open excavation, and their borings are come in picture. What are actually boring? Boring methods or bore holes are the small diameter holes which are supported with the casing or without casing and extended up to a very large depth. It may be up to 20 meter, it may be up to 25 meter. It's Then there are methods of boring, and that methods of boring are changed according to the soil conditions available over the site. So first part of boring is a auger boring. Auger boring is a simplest method of exploration or sampling where the power driven or hand operated augers can be used. The augers are maximum used up to a depth of 10 meter, and it is suitable for the soft soils only. Soft soil without water table, or with water table, if there is a water table, in that case the casing is suggested to provide. Then this is actually the hollow stem used for sampling. You can see these are the augers. These augers are just similar to the drilling machine that we are using in our daily routine life just to make a hole into the wall. So here these are the bigger size drill which are used to make the excavation up to a large depth. Here there is a simple drilling rod, hollow drilling rod, which is connected with the handle at its cross handle at its top and having cutting shoes at its bottom. Just by giving a downward thrust and rotating it, it will make a hole. So these type of augers are the augers which are automatically cut the soil is automatically rotated and the casing is automatically rotated. So these are the augers which are auger will make the hole and cut soil is plugged by the post hole auger. This is the hand operated auger. But where the hand operated augers are used? These hand operated augers are used up to a certain depth only when the soil is become a soft one. When the soil is become hard and the depth of exploration is increases, in that case these power driven augers are nowadays most commonly used. Then if the soil is become harder or stiff, in that case the auger boring method can be used. Then it was inserted. As the soil is in a very hard condition, the drilling fluid or water is inserted into the drilling rod through this pump and the hose pipe. This is the hose pipe and this is the pump. The water is coming through the sump to the pump to the hose pipe, and hose pipe to the drilling rod. Then that water is coming over here with a very high pressure, and due to the high pressure and continuous chopping bits, the soil over here is getting pulverized, and the liquefaction of the soil at the bottom of the hole is taken place. Then whatever soil slurry is formed over here, that soil slurry is coming out through the annular hole between the casing and the drilling rod, and that is again collected over here into the sump. You can see this is the actual arrangement. Here you can see these are the drilling rods, which are hollow pipe. Then this is actually the drilling rod. Hello, अभी देखो रोटरी ड्रिलिंग है. अभी कौन सा है? वॉश बोरिंग. बाप रे, मैं तो बहुत पीछे चली, बहुत खूब आगे के चली गई हूँ मैं. हेलो, अभी तो ये बाप रे, मैं तो बहुत आगे गई हूँ. अच्छा ठीक है. So this is the wash boring method. You can see this is the wash boring method. Here, this is the wash boring method. Here you can see this is the annular hole which is placed over here, and this is the drilling rod. Drilling rod, hose pipe, this is casing. The water is coming out through this and collected over here with this sump. So this is the diagram from just the color of the slurry. You can see this is the color of the slurry. From the slurry color you can identify which type of soil is there. Suppose this is the grayish type of soil, and if this soil color changes to reddish, so in that case we can say that the soil is changed over here. Means whatever soil type was available up to a 3 meter, 3 meter ke baad mein, after that the soil is becomes changed. So this is called as wash boring method. Then the third method. Now suppose the soil is now in a hard condition, very hard condition. In that case, the previous method, that is auger boring, is not suitable. Secondly, we cannot go for the wash boring also. In that case, the rotary drilling is come in picture. So borehole is made into the hard soil or very stiff soil. A drill head at the top drill rod consists of a rotary mechanism and the arrangement for applying downward pressure. You can see this is the rotary mechanism. This is the rotary mechanism. A very high pressure is provided through the rotary mechanism. You can see there is a augers, and here these auger are having a cutting bits over the rod. There are two types of augers which are used over here. Here you can see this is the soil which is cut. The soil is fixed into the blades of the auger, which is further removed. So this is called as the rotary mechanism. So this rotary mechanism is used. Drilling fluid under the pressure is introduced through the drilling rod for the use in material containing a large percentage of gravel. Then the fourth method is percussion drilling. If the soil is in a very hard condition or the soil is containing some rocks, in that case, these all the three methods cannot be suitable. In that case, we will go for the percussion drilling. Here in the percussion drilling, a heavy chisels are attached at the bottom of the rod. Here suppose this is the tripod and this is the heavy chisels which are placed at the bottom. Then there is a continuous lifting dropping, continuous lifting and dropping of the material. The soil below it, suppose here you can see these are the heavy chisels which are lifting and dropping, which pulverize the rock over here. Then the water is added from the top, and it is converted into the slurry. Then whatever slurry is created over here, that is being collected and lifted by the by the sand pump. So this is third method, that is called as percussion drilling. So here the percussion drilling method is mostly suitable for the rock. This method is used for making hole into the rock, boulders and other hard strata. A heavy chisel is alternatively lifted and dropped in the vertical hole. The material gets pulverized where the chisel strikes, which is removed with the help of sand pump, and it is not possible to get a quality undisturbed sample. So this is the percussion drilling. Then the last method is the method of boring is core drilling. So in this core drilling, basically the method is completely suitable to get the rock core. You can see these are the rock cores. Here the diameter of the rock is around 38 centimeter and the length is whatever is the length. In this case, directly this intact core of the sample is tested into the laboratory just to know the just to know the compressive strength of the rock. So basically this method consisting of a rotary mechanism and the barrels. You can see this is the this is the drilling rod, and drilling rod is attached with the sampler. There are two or three barrels are attached over here. The annular hole is cut through the outer barrel and the sample is collected into the inner one. These are connected, or the chopping bits are made with the material to get the soil sample into the core. So this type of core is enters, and once the samples are collected, you can see this is the sampling method. These are the samples which are collected at different level. Suppose I have started it from the rock is obtained at 3 meter depth. It will be started from 3 to 4 meter, then 4 to 5 meter, then 5 to 6 meter, 6 to 7 meter. Like this it is being placed into a different uh, cases. And here, as per the depth, the markings are made over here. Suppose in this area, whatever green portion in this area, suppose the rock core is not obtained properly. If suppose there is in the slurry form, in that case it will be placed the line, or suppose it is obtained in the gravelly form, then that gravel is placed and the distance is mentioned over here. Okay. So here So here we can see there are boreholes. So this is the borehole. Now what exactly the purpose of making boring? Boring is carry out just to take a soil sample at different levels. Suppose I just wanted to take out the soil sample at different depth. Suppose at 1.5 meter depth, then at 3 meter depth, then at 4.5 meter, 6 meter, 7.5 meter. Like that, the soil samples are taken. So once I want the soil sample at 3 meter depth, then what I will do? I'll just make a borehole up to a depth of 3 meter. Then I will remove the drilling bits, attach the sampler at the bottom, and just by giving the pressure, the soil sample is enters into the soil. Once it is filled with the soil, it is being lifted up, removed, and the further soil, the borehole is continued. Like that, at different stages, we will take out the soil sample into the borehole while making the borehole itself. Just by making or just by driving the borehole, the samples are taking at different level. First, make the hole up to a depth of 1.5 meter, take out the sample. Then make the borehole at 3 meter depth. Then at 3 meter, you take the sample. Then at again, we will carry out or we are taking out the soil sample at every 1.5 meter interval, or where there is a change in the strata, whichever is less. Suppose I have taken the soil sample at 3 meter depth, and immediately at 4 meter depth, if there is a change in the strata, I will take the soil sample at 4 meter also, right? After that 4 meter, again after 1.5 meter, I will take a one more soil sample. So like that, the soil samples are taking out. Again, whatever soil samples we are taking out, again it will be depends upon the type of sampler that you are using during the sampling. So now, different types of samplers that we are using to take out the sample, that we will discuss now. So the type of samplers which are used to collect or to take the soil sample at different stage. So the first one is split pun sampler. This is the most commonly used type of sampler. It is just to get a disturbed sample when there is no liner. You can see this is the sampler which is having a cutting shoe at the bottom. You can see this is the cutting shoe at the bottom, which is 7.5 centimeter. This is attached over here. Then this is the coupling. This coupling is 15 centimeter length, and it is at the top, and the sampler is at the middle. You can see this is the sampler which is split up into a two parts. Split up into a two parts. When such type of sampler is used with the liner, you can see this is the liner which is inside over here, or which is inside into the sampling tube. When these, it will be carrying a liner, then it will gives you a proper quality of undisturbed sample. When it is used without a liner, then it will gives you a disturbed quality of sample. And generally, this type of sampler is used for carry out the standard penetration test. Then the second type of sample is called as scraper bucket sample. Scraper bucket sampler is used for if the soil containing gravels or pebbles. In such cases, the above sample cannot be used. Sometime during the driving, some pebble or some gravel may come into it and it will block the way. So in that case, we will use the another type of sampler which is called as scraper bucket sampler. If the sandy deposit contain pebbles, it is not possible to obtain sample by split pun sampler. In that case, we will go for the scraper bucket sampler. Here you can see this is the scraper bucket sampler which is attached with the drilling rod at its top and the driving shoe at the bottom. Here you can see this is the driving point. That driving point just placed at the bottom of the borehole, and we will just rotate it. While rotating, there is a vertical slit. You can see this is the vertical slit which is available over the sampling tube, and we will rotate it opposite to the direction. While rotating it, it will just scrap the surrounding material, and that scrap material is enters through this slit into the bucket. This is called as bucket. Here you can see this is the bucket. So through this slit, the scrap material is enters into the bucket. Once the bucket is being filled with the scrap, then it will be removed up. Then it is clear, make it clean, remove the soil sample, and again put it into the drilling hole. So this is called as scraper bucket sampler when the soil containing pebbles or gravel. In that case, we cannot use the split pun sampler. Sample is obtained by this highly disturbed sample and used for just to determine the index properties of the soil. Then the third type of sample is called as a thin wall open tube sampler. It is also called as shell pie tube samplers, which are used for soils that is particularly a sensitive of sampling. Generally, a soil that is soft cohesive soils are used, or the samples in the soft cohesive soils are taken with the thin wall samples only. This is a very sensitive type of samples are there, which shows a very degree of disturbance is very less. Whatever soil samples we will obtain, it is completely a intact stage, and the proper undisturbed quality of sample we will obtain through this. Then the third type of sample is piston sampler. Now piston sampler is mostly suited for taking out the soil sample which is very sensitive or very soft type of soils are taken with the help of a piston. So here you can see this is the arrangement where piston is attached at the bottom of the sample. Here you can see this is a complete sample, and this is the rod, where rod, at the bottom of the rod there is a piston, and this piston and the sampler, here you can see this is the liner of the sampler, where we will insert the sampler with the piston into the soil by hammering. Once the sampler is completely inserted into the soil, the piston is only lifted up. The sampler is over here itself, only the piston is lifted. You can see here the piston is only lifted up, and that lift, during the lifting of the piston, this air is, by the squeezing action, the air is over here above the sample. It will try to keep the soil in an intact stage. While squeezing, the air or vacuum is created over here, which will help to retain the soil sample in an intact stage. So this is similar to the pump. Just while taking out the piston, the vacuum is created by the squeezing action, and that vacuum will help to retain the soil sample in an intact stage. So this is called as piston sampler. It consists of a thin wall tube with the piston inside. The presence of piston prevent rapid squeezing of the soft soil into the tube and reduces the disturbance of the sample. The vacuum created by the squeezing action helps to retain the soil sample in an intact stage. So this is the just take a wooden box which is closed from all the side, and at the top it will be, at the top it will be open. Then that open box we will place over the soil column. We'll make a soil column, isolate the column from surrounding soil, and then we'll trimmed off from its bottom. Here you can see this sample is in an undisturbed condition and suitable for carry out all the further test. This is the open drive sample. This is possible in a borehole where the bigger size sampler is inserted into the soil. Take the undisturbed sample. So this is the can be obtained if the soil is in exposed or it in a test pit, shaft or tunnel. It is known as a chunk sample. The soil should at least have some cohesion so that it can stand unsupported for some time, and the samples obtained are undisturbed condition of soil. Then whatever samples we have obtained from all the five types of samplers, how many samplers we have discussed? One is split pun sampler, second is scraper bucket, third one is open tube sampler, fourth one is piston sampler, and fifth one is a chunk sampler. Out of all the samples, five samples, some samplers gives disturbed sample, some samplers gives undisturbed sample. So whatever samplers we have obtained, samples that are broadly divided into two types, that is disturbed sample and undisturbed sample. Now, what is disturbed sample? Again, disturbed samples is further divided into two, that is remolded soil sample or representative soil samples. Remolded means, once, suppose the soil which we have obtained from the scraper bucket sampler, it is completely in a disturbed condition. But that completely disturbed samples we will place into a sampler and remold it. Then it will be a in a remolded condition while it is representative. And another type of sampler is a not representative, means it will not shows you a proper soil property. Suppose whatever samples we are getting from the wash boring, the soil sample comes under the slurry form and it will be a mixed one. In that case, it will not represent any of the soil. In that case, it will be called as non-representative. And some of the sample, even though it is in a disturbed condition, but shows a some properties, that is representative. Then what is UDS, that is undisturbed sample? It is a true in situ sample which is obtained from chunk or block. So these are the types of sampler. The disturbed samples are used for taking out index properties, whereas undisturbed samples are used for carrying out shear strength, permeability, and compressibility, means engineering properties of soil. Then here, undisturbed samples used to determine engineering properties, that is density, water content, shear strength, and wash samples obtained from wash boring, that is in the form of mud. Then representative samples retain all constituents of soil but disturbed from natural state and structure, where the split pun sampler may be used. Then block sample or chunk samplers, which are used from the open excavation, and it is sealed in the sealed form and used for carry out the test, that is engineering test. Then whatever samples we are using, that should be having some specification, and that is called as design features. So the design features consisting of area ratio, inside clearance, outside clearance, and the recovery ratio. These are some of the things. Here you can see this is the sampler which is having cutting shoe at the bottom and sampling tube over here. So here, this is internal dimension of the cutting tube, external dimension of the cutting tube, internal dimension of the sampling tube, and external diameter of the sampling tube. So these are some of the design features which is called as inside clearance, outside clearance. So area ratio is the uh, ratio of outer diameter minus internal diameter divided by internal diameter and into 100. It should be numerical value should be less than 10%, then it will shows you a better good quality undisturbed sample. Once we will go, whatever method we have discussed earlier, all that methods are useful for getting the soil sample. Now, after the soil sample, there is a rock core. So rock, when we are considering rock core, it will be, there is a recovery ratio, and RQD is the most important parameter that we have to check just to know the quality of rock. That recovery sample is the length of sample recovered to the length of run. Means suppose the length of the run is 1 meter, and suppose we will obtain the run of, means a single piece of suppose 10 centimeter. So that 10 divided by 100 means only 10% recovery ratio is there. In that case, that soil may not be that sample may not gives you a good representation of a particular source. Therefore, the recovery ratio should be more than 90%. In that case, it will shows you a better result. Here you can see this is the small soil sample where the run length is 1 meter, but this is the small sample. Suppose this is the 10-meter depth. Here the recovery ratio of this is 10%, whereas this is the complete intact soil, intact rock core. Here recovery ratio is 90%. In that case, we will just discard this sample and we'll go for this sample because it has a good recovery ratio. So after taking out, making the borehole, taking out the samples at different stages, then all that samples we are sending it into the laboratory for the investigation. Once we collect all the data from the primary investigation, from the detailed investigation, from the SPT, or it may be from the plate load test, all that data we are using in the concise form, and that is called as the report. So here
That report represents the description of the site condition, means what is the topographical data of the or features of the soil condition, at which depth there is a soft layer, then at what depth there is a murum, or at what depth there is a compressible layer, hard strata is available at what depth, what is the depth of the hard strata, what is its strength, then where the water table is lie. All these things are collected from different boreholes, from different samples. All that data is make into the concise form, and that is called as a geotechnical investigation report. So description of site condition, topographic features, hydraulic condition, existing structures, supplementary by plans and drawing, then all that data is represent into a concise form, which is the important for proposed construction. Description of field and lab test carried out, analysis and discussion of data collected, preparation of charts and tables and graphs, and calculation performed. And lastly, whatever data obtained, the recommendations are given. Now, that recommendations are in the form of the concise report. There is a concise report, all the test data is given into that concise report, and lastly, the recommendations are given. Suppose whatever is the purpose, means as per the recommendation, at 5 meter depth there is a hard rock available. Here you can go for the open foundation, or you can go for the isolated footing. So these recommendations are given by the geotechnical expert. So once this recommendation is given by the geotechnical exploration, then the whole report is sent to the structural designer for carry out the further investigation or further design. So this is the complete thing. So these are the references. Uh, with this, I conclude the session. Before